Okay, we are finally ready to actually algebraically find general solutions. And when I say general solutions, I'm going to connect this to what I either said. General solutions is the same thing as family of solutions. So we're finding our family, that's our plus C. Finding our family of solutions to differential equations. We're finally going to algebraically be able to solve this. So if we have a derivative of y with respect to x, and that equals y sine x, how can we find the actual solution to this algebraically? Well, this is part of why math notation is so important, because it allows us to do really clever things. And what it allows us to do here with this dy over dx, and we're doing something that we're not supposed to be able to do, but we're doing it. We're going to separate this. This looks like dy divided by dx. What is the opposite of division? Multiplication. So let's multiply both sides by dx. So times dx times dx. And we end up with dy equals y sine of x times dx. And now, not super sure what to do here. Like, I don't know how to work this yet, but what I can do is I can divide by y and at least get my y's on the same side and my x's on the same side. So divide both sides by y. And we get, I'm actually going to write it this way, 1 over y dy equals sine of x dx. And looking at this, I still don't super know what to work with this. But what can we do that would get rid of this dy or this dx? And I'm going to reframe it as, what can I do that gets rid of this derivative of y? Or this derivative of x now? Well, what is the opposite of a derivative? That is an integral. Integrals are antiderivatives. They are the opposites of derivatives. They undo each other. So let's integrate both sides of this. What is the antiderivative of 1 over y? Well, that's ln of the absolute value of y. And I'll do this on the first one, and then absolute value y plus c. Actually, I'm going to choose a different letter. Let's say plus a. And the reason why I'm doing that, I'll explain in a second when we get to the end, so we can sort of see what's happening and I can make it streamline our process. And then what's the antiderivative of sine of x? Well, that's negative cosine of x plus b. And we're going to solve for y still, because we want to find y. That is going to be our general solution, is y equals something. So let's subtract a from both sides. We get ln of y equals negative cosine of x. And then this is going to be b minus a. Well, I'm just going to call that c. And so moving forward, when we do this integration, we only need one constant on our side. So I'm just going to, from moving forward, I'm going to add my plus c to this right-hand side when I integrate. And I'm not going to worry about doing the constant on both sides, because this is just a number, this is just a number, it can be whatever, it is whatever number, and we subtract them and it gives us this. This is still just a number, we don't know what it is. So we really don't need to write it out both times. And now, hopefully you remember this from pre-cal, how to solve for y if you have natural log of y. What we do is we exponentiate, we raise to the power, or it's not raising to the power of e. We make this our exponent. And how do I get rid of natural log? Well, the inverse of natural log is e. So I'm going to raise, make both of these exponents, will it load? Is it loading? Yeah, to e. And then what happens when we continue with that is this e and this ln, they undo each other. So we're just left with y equals e to the negative cosine x plus c. And we could leave it like this, but I'm going to take it a step further. I'm going to have us use our exponent rules. Well, when we're adding exponents, what can we do? We can change it to multiplying. So y equals e to the negative cosine x times e to the c. And this e to the c is just a constant. And I'm actually going to rename it because I'm being a little forward thinking. We're going to rename this as q. Instead of leaving it as e to the c, because this is just a number. E to the c is just a number. And so it becomes y equals q e to the negative cosine x. Truthfully, if you get to this part here, for most cases, or at least for now, until we get to some problems later on, this part here is good. This part here is what we're eventually going to need when we get to bringing this back to the practical application. Because if you remember, I started this with us writing differential equations. Eventually, we're going to get back to that. We're going to have to write differential equations and solve them. And we'll have to solve it when we go a step further than we're going here. But this is our general solution to this differential equation. Now, moving to part 2. It's going to be the same idea. We're doing separation of variables. So I'm going to multiply by dx, and I'm going to do two things at once, and I'm going to move this 5 cosine y to the other side. So I'm going to get 5 cosine of y dy equals 3x squared plus 2 dx. And really, you don't have to move the 5 if you don't want to. You could leave it there, but I just don't want to deal with the fraction, so I'm moving it. And now we have this. How do we get rid of our dy and dx? We integrate. And we integrate both sides. What is the integral of 5 cosine y? Well, that's going to be 5 sine of y equals the antiderivative of 3x squared is x cubed. The antiderivative of 2 is 2x. And then make sure to put your plus c at the end on the right-hand side. We're solving for y, so divide both sides by 5. We get sine of y equals x cubed plus 2x plus c divided by 5. And I just want to make another observation here. There's another way I could write this. This is just a constant of a number we don't know. This is a constant divided by a constant. If I wanted to, I could also write it as x cubed plus 2x divided by 5 plus c. This is actually the same thing because dividing c by 5 doesn't matter. Because we don't know what that number is, but it's just a single number. So you could see it written like this, or you could see it written like that. I'm just going to deal with it like this because I think that'll make more sense to y'all for now. And then how do we get rid of sine? Well, we do sine inverse. So we get y equals arc sine of x cubed plus 2x plus c divided by 5. And boom, that gives us this one. And this is our general solution to this differential equation. Okay, Go ahead and try number 3 on your own. Pause the video and try it. And when I come back, I'm going to have all the work done and we're just going to talk through it pretty quickly. Okay. And coming back, I multiply both sides by dx and multiply both sides by y. Got the integral of y dy equals the integral of x plus 1 dx. The antiderivative of y is 1/2 y squared. The antiderivative of x plus 1 is 1/2 x squared plus x plus c. Multiplied both sides by 2, and again, I'm writing it as plus 2c, but that's also the same as just plus c. Like these, you don't have to multiply the c by 2. And then I square root, and when we square root, remember we lose the uniqueness of the sign, so we get plus or minus this. And this is our general solution. For this one, try number 4. Go ahead and pause the video, and when I come back, I'll have this one, we'll talk through it really quickly. Okay, coming back, again, same idea, multiply both sides by dx, and then divide both sides by y to separate the variables, and then take the integral of both sides, because anything we do to the left, we do to the right. The antiderivative of 1 over y is the natural log of the absolute value of y. The antiderivative of x squared is 1/3 x cubed plus c. How do we get rid of this natural log? Well, we exponentiate. We make these powers of e. So we get, and that natural log and e undo each other, and we're left with e to the 1/3 x cubed plus c. And then I went ahead and I did what we did before, where I just took this and split it out into the q being a constant of e to the c in the front. And something I'm realizing that I probably should elaborate on a little bit. Is this idea of what rules do we need to follow for c? So like I said here, we don't need to multiply c by 2, and I said here we don't need to divide c by 5, but here I am raising c to that power. These are just sort of math rules about the way numbers work. When we make it a power, that needs to come with it. Otherwise, it's not going to be the same. It changes it if you don't do that. And same thing with here, putting it inside the square root, it changes it if it's inside the square root or outside of the square root. Compared to it just being a number. So that again, not the super best explanation, but if you ask me in class, I can explain it better. But basically, if we're multiplying to c, if we're adding to c, if we're subtracting to c, if we're dividing to c, it doesn't matter. Everything else, it does matter. So if we're square rooting, if we're, or no, I take it back. If we're square rooting, it matters. If we're if we're square rooting, it matters. If we're squaring, it matters. All the other things, they matter. It's specifically if we're adding, subtracting, multiplying, or dividing that it does not matter. Okay, this one here, I'm actually going to help us with this first part here. This is part of why I did this other exponent rule, because this, how do I separate this? Well, our first piece in separating this is actually going to be using our exponent rule. We get 3 to e to the 2x times e to the 5y. Since we are just adding these exponents, we can rewrite that as multiplying it. And now I want you to pause the video and try and figure out the rest on your own. Okay, and I'm actually going to come back a little bit before I finish because this problem's doing some interesting things. So first off, we get this 1 over 5 e to the 5y when we divide by e to the 5y. Well, we don't know how to integrate that, but we do know how to integrate e to the negative 5y, so we just use our exponent rules to make this, just change the exponent to be negative and we can put it in the numerator. And then we still need to do a trick here, which I didn't write out this trick. Perhaps I probably should, but I'm going to... No, okay, I will. I will write it out. I'll write out a piece of it. we need to have u equals negative 5y. And we also need to have, I'm going to choose a different letter than u. I'm going to choose v equals 2x. And we need to do a u substitution here in order to integrate this. But hopefully you caught that and you were able to do it. But you do your substitution. The antiderivative of this is negative 1 over 5 e to the negative 5y is equal to 3 halves e to the negative 2x, e to the 2x plus c. Okay, and now from here, the first part should be clear. We're going to multiply by negative 5 on both sides. So we end up getting e to the negative 5y equals negative 15 over 2 e to the 2x plus actually no, I'm just going to write it. I'm just going to write it as plus c. Because we're multiplying, that doesn't change the value of c, so I'm just going to leave it as plus c. And now, how do I get rid of this e? Well, similarly, how the inverse of natural log was exponentiating with e, well, now we're going to take the natural log of both sides. So if we natural log both of these, we're going to get negative 5y equals the natural log of negative 15 over 2 e to the 2x plus c. And remember, the only thing that we can ignore for c is adding, subtracting, multiplying, dividing. If we're doing a natural log, we need to put it inside our thing. And then we divide both sides by negative 5. Divide by negative 5, we get y equals the natural log of negative 15 over 2 e to the 2x plus c divided by negative 5. Sorry, I'm just moving my thing down a little bit so I have space. Is there a way we can go further with this? I know I put it on your cheat sheet, our log rules, but I'm blanking, so I'm gonna look it up really quickly. If we can simplify this any further, I think we can. I suspect we can. Our product rule. No, we cannot. Okay, we cannot simplify this further. If these are being multiplied, we could simplify it further, but we can't. Okay, I just wanted to make sure. Okay, and that makes sense, that multiplication becomes addition, because it's the inverse of e, where addition becomes multiplication. Okay, last one, try it on your own. Then come back, nothing super fancy in this one. I will tell you, you need to use u substitution here. Okay, nothing super fancy happened here. We had to use u sub for 4y and 3x. But the antiderivative sine of 4y is negative 1 over 4 cosine of 4y. If I want to check that, I can differentiate this. What is the derivative of negative 1 over 4 cosine 4y? Well, that's going to be positive sine of 4y times 4. Positive sine of 4y times 4. Negative 1 over 4 times 4 is 1. That checks out. Okay. Moving to cosine of 3x dx, the antiderivative of that is 1/3 sine of 3x. You can take the derivative of this and check me if you want to. Multiply both sides by negative 4, so we get cosine of 4y equals negative 4 over 3 sine of 3x plus c. And here, remember, we're multiplying to c, so it doesn't actually change anything. And then how do I get rid of this cosine? Well, I do the inverse of cosine. So 4y equals cosine inverse, or you could have written arc cos, that would also be okay, of negative 4 over 3 sine of 3x plus c. And then finally divide everything by 4 to get rid of that, and we get y equals that. And here's our general solution. Boom. Okay, there are 3 more examples that I want to do that cover slightly different things. But again, I think you can try it on your own. And then we'll just see what happens. So go ahead and pause, try this one, see if you can figure it out. And then when you unpause, we'll come back and we'll talk about it. Okay, this is as far as I expected you to get on your own. If you got further than that, good job. Like this is tricky. This is not intuitive what's happening here. But we don't have any y's to get over there, but we still have this dy. Well, there's an invisible 1 there. And let's just integrate 1. And what is the integral of 1? What is the antiderivative of 1 with respect to y? Well, that's just y. And here, this one, the antiderivative, ln of 2 is just a constant. So I can really just pull that out if I wanted to. But the antiderivative of 1 over x, is ln of x. So we get 1 over ln of 2 times ln of the absolute value of x plus c. So ln of 2 is just a number, it's just a constant, so I can pull it out, and then just the integral of 1 over x, the antiderivative of 1 over x is ln of absolute value of x. We get that. Boom. Done. Second one. Go ahead and try it on your own, and then we'll come back and we'll talk about it, and I'm going to talk about this one pretty fast as well. Okay, and coming back, I did show my u substitution here, more or less. But we separate the variables. We get cosine of y times dy equals cosine of x times e to the sine of x dx. Sorry if that was a little hard to see. I'm realizing that now, but whatever. And then we integrate both sides. What is the antiderivative of cosine of y? Well, that's just sine of y. And here, we have cosine x times e sine of x. Well, I don't know how to integrate this, but I noticed that the derivative of sine of x is cosine of x. So let's do something with that. Let's do u sub, u equals sine of x, du equals cosine x dx. So this cosine x and this dx becomes the du, and we're just left with e to the u. And I know the antiderivative of e to the u. Well, that's just e to the u. My u is sine of x, so I have e to the sine of x plus c. How do I get rid of this sine in the front? Sine inverse or arc sine. Y equals sine inverse of e to the sine x plus c. And here's our general solution. And last one, this requires you to do something we have not done with this specific topic, but we have done a lot in this class. I want you to try and do it on your own. And then unpause the video, when we come back, we'll talk about it. Okay, so coming back, what you should have recognized you have to do is these terms both have a common factor of the square root of y. We should factor that out, and we're left with 1 minus sine of x, and then from there it's just our separation of variables, multiply both sides by dx, divide by the square root of y. And I actually took my time and showed the work for this because on video I haven't showed it much, although we're going to practice it in class, so surely at this point y'all know it. But this is the same as y to the negative 1/2 dy. The antiderivative of this, well, we're adding 1, negative 1/2 plus 1 is 1/2, and dividing by our new thing, dividing by 1/2. The antiderivative of 1 minus sine x, antiderivative of 1 is x, antiderivative of negative sine x is cosine x plus c. Dividing by 1/2 is the same as multiplying by 2, so all I did there was change this to a 2. divide everything by 2, or multiply everything by 1/2. In this case, I multiplied everything by 1/2. And then you square both sides to get rid of this. And 1/2 squared is just 1/4. So we get 1/4 x plus cosine x plus c. C squared. Okay. And that finishes up all my examples on separation of variables. And believe it or not, we're actually almost done with this unit. I have two more videos I'm planning on making, and then we're moving on to Unit 8. Thank you for watching.